Hey, as promised, here I am. Gonna go over number 1 and number 2 of finding oxidation numbers, right? So it's not that bad. We've done it before. It's just like finding the charge of a metal when there's more than one option. You guys remember doing that, finding the Roman numerals when your name and stuff. Don't act like you don't love it, because I know you do. Let's dig into it. So look, here's number 1. We need to find the, let's go with the pens. We need to find the oxidation number for chlorine in this compound KClO4. Here's how we're going to do. First thing I'm going to do is I'm going to write K, Cl, and O. O4, right? And then I'm going to draw a line. And just like we did with the charges for metals, the first thing we're going to have here is the number. So how many potassiums do we have here? We have one potassium. We have 1 chlorine. And how many oxygens do we got? 4. Absolutely. Now, the second line, before we said charge, right? But, it's now that we're in redox, we're going to call this the oxidation number, right? So what are the oxidation numbers? You got to use your periodic table of the elements. All right, so hold on for a second. I'll be right back. I wanted to bring up this here for you. Boop, there you go. Because look, here we got the periodic table of the elements, and look right here we have all the charges and stuff like that. So potassium is right here, right? You guys see potassium right here, right? It's got a charge of +1. Sweet. So coming over here, my potassium is a +1. Now the chlorine is the one in question. So, we're going to use the mathematical symbol for I don't know, but I'm going to find out in a few minutes. And let me click on over here for a second. Check this out, man. Look at chlorine. If chlorine is on the left, it's going to be positive. If it's on the right, it's going to be negative. But what if it's in the middle? We don't know, because dude, look at all these options: -1, +1, +3, +5, +7. Those are just some of the possible oxidation numbers for chlorine. So we really have no idea what it's going to be, which is why we got to do this mess right here to try to figure out what it is. So we're finding chlorine. We don't know what it is, so we give it an X. Now, oxygen, you guys remember the rules. Oxygen is always going to be a -2. And now we multiply up and down. It works like this. We have 1 potassium. Each potassium has an oxidation number of +1. How much in all? 1. We have 1 chlorine. Its oxidation is X. How many in all? Right? We have 4 oxygens. Each oxygen is a -2. How much in all? Exactly, right. Now, I want you to look up here in this corner and notice how there's nothing there, right? So that means that all of these oxidation numbers are going to add up to 0. You dig what I'm saying? Basic algebra. 1 plus x minus 8 equals x. So let's add 8 to both sides. So 1 plus x equals 8. Now we are going to subtract 1 from each side. That's all there's to it. Want to try another one? I'm sure you do. Let's try it. For this one, we've got nitrogen in barium nitrate, BaNO3 2. All right, so first thing I'm going to do is I'm going to write out the whole thing. Okay, and now we write down the numbers. I chose this one because it's going to be a little bit spicy, because look, we have a polyatomic ion, we have parentheses, we got a lot of stuff going on. But we can figure it out. How many bariums? 1, because remember here is where we put the number. Now how many nitrogens? Well, 1 nitrogen. There are 2 polyatomic ions, so 2 times 1, 2 nitrogens, right? Oxygen, there are 3 in each polyatomic ion. We have 2 polyatomic ions. How many do we have in all? 2 times 3. 6 oxygens. Sweet. Now we're going to do the oxidation number. for barium. I don't actually have that memorized, so I'm just going to come over here to my handy-dandy periodic table of the elements. Oh, barium, right here. Group 2 plus 2. See, I didn't even need to memorize that stupid rule. It's just right there. I can just look it right up. So barium is going to be plus 2. Nitrogen, well, that's what we're trying to find. That's going to be my mathematical symbol for I have no idea. And oxygen is always minus 2 because that is decidedly not a peroxide. So we're going to go like this. And just like before, we have one barium. Each barium has a charge of plus 2. How much do we have in all? Plus 2, 2 plus. I don't really care which way it all works out in the end. We have 2 nitrogens. Each nitrogen is going to be an X. How much in all? Well, 2 of the I'm not sure yet. We have 6 oxygens. Each oxygen has a charge of minus 2. How much in all? What is 6 times 2? 12. And again, if we come up here, if you'll notice there's no charge here. There's nothing there, so this all adds up to 0. 12. Right? Because I'm going to add 12 to both sides. Then I'm going to subtract 2 from both sides. And now if it's 2x minus 10, I'm going to divide both sides by 2. Plus 5. 5 plus. Okay, here are the acceptable answers. I will allow plus 5. I will allow 5. I will allow 5. I will allow 5 plus, and also just plain old 5, because they all mean positive 5. That's how you do. If you need more help, shoot me an email, shoot me a text, post the message up on the board. Whatever you need to do, guys, let me know, and I'll be here to help you out. Hope you guys have a great day.